Hi guys, hope you saw my previous video on the preparation of integration by parts. Today I'm going to go through some examples with you. Feel free to pause where necessary. Hopefully things fall into place. Enjoy. So it makes sense for us to look at the integration by parts formula. If you remember from my last video, we have to be able to look at a question. There will be two expressions there, and we have to define which one will be represented by u, and that's the one we differentiate, and which one is going to be represented by dv dx, and that's the one we integrate. So we're going to look at our first example, which is the integration of 3x cos x against dx. Now, by looking at that, we can clearly see two expressions there, one of them being 3x, one of them being cos x. And because 3x is part of the x to power n, then we can represent that by the letter u. And that's the one we're going to differentiate. So we're going to start off with u equals 3x. Underneath that, we're going to write our expression that is going to be integrated. And that's the dv dx. So dv dx is equal to cos x. Now I like to write it one on top of each other, so next to it I can then write what I need to get from my differentiated answer here. So du dx, that's the one I'm going to differentiate, which is 3. And here we're going to integrate. Now we're going to integrate cos x to find v. So many confusions in the past amongst students. Does cos x become negative sin x? Does it become sin x? Don't get confused with differentiation. We are now going to integrate cos x, so that becomes positive sin x. Now looking at the formula, it starts off with the integration of u dv dx against dx. In other words, we're going to look at the question here. So we're going to write out the question, which is 3x cos x with respect to x equals. Now we're going to start off. It starts off with uv. In other words, we're going to multiply these two together. So we can write 3x sin x. And if you look at the formula, it starts off with minus. Now we're going to integrate these two by multiplying these two together. But preempt this, I've got a constant 3 there. I like to take the 3 out, and then whatever expression's left inside, we can deal with when we integrate. There is no harm in leaving that 3 inside to call it 3 sin x. I just like to get the 3 out, and then you're dealing with something a lot more clearer. So we now have to drop the 3x sin x. I'm going to write a minus, and again you have to preempt this. We're going to integrate sin x, but the integration of sin x is negative cos x. That negative cos x with that negative will then become a plus, and we have 3 cos x. And that is where you'd end it. Now remember, we have no limits on our integration, so we can end with an arbitrary c, and that's what you should end up with, 3x sin x plus 3 cos x plus c. Now that is quite a simple question. We're going to go to our next example, which is slightly harder, slightly longer, and you'll see that in a moment. So our next example is x squared e to the power minus x dx. Now, a number of reasons why this is a little bit more difficult. I have an x squared there, and I've got the exponential there. So we need to separate this again. I've got two expressions there. And again, it's quite clear that x squared and e minus x can be separated. As x squared is part of x to the power n, then it makes sense for us to write u equals x squared. And the other expression would be dv dx equals e to the minus x. So we know that we're going to differentiate the x squared, and we're going to integrate e to the power minus x. So, same principle as in the last example. So we're going to start off with du dx, nice simple one, and that's 2x. We have to now integrate e to the power minus x, so that's going to be v equals. So when we integrate e to the power minus x, because there's a negative there, that negative is going to go underneath or on the side, so we're going to have minus e and then paste the minus x. If you look at the question, we need to look at how we're going to substitute that into our formula. So we're going to start off with the question, and the question being integration of x squared e minus x dx equals, and it starts off with uv. Now uv, these two. We're going to multiply these two out. So look at the negative. That ideally should come first. X squared e minus x. That's the uv. Put a default minus because that's part of the formula. And now it says integration of v du dx against x. So in other words, these two. If you remember from my last example, if you see a constant there, take it out. But I also see a negative. That negative with this negative will become a plus. So there's quite a lot to think about before you start to integrate. So I'll say that again. There's going to be a 2 that's going to come out there. That negative with the formula of the negative becomes a plus. And then I'm going to integrate x e minus x dx. And this is the v du dx. So I have to look at this. This is not as easy, and you notice here I'm going to have to repeat my integration by parts because I have two expressions here, one being x, that can ideally be u, and I've got an e minus x, that could be my dv dx. I get an answer to this. I then need to multiply by the 2 and then add on my minus x squared e minus x. So that's what we're going to start off with. We're going to look at this. Okay, so here u can equal x. dv dx is e minus x. Differentiate that, so du dx equals 1. And like before, v, when we integrate it, will be minus e minus x. So just on this alone, when we do the parts, we're going to end up with uv, which is minus x e minus x, minus part of the formula, and we're going to integrate these, the product of these two. There's another negative there, so I call that add. The 1 we can discount, and we can integrate e minus x with respect to x there. When you integrate that, we're going to get minus x e minus x minus e minus x. Now this is the answer to this part here. Now remember, there's a 2 there. So to tidy up, we are now going to have minus x squared e minus x plus 2, open bracket, put our answer that we just got here, close bracket. And all we got to do now is open up the bracket. So we have minus x squared e minus x minus 2x e minus x minus 2e minus x, and we have our arbitrary plus c there. See if we can cancel, and by looking at this, there's nothing to cancel here, and that would then be our final answer. Minus x squared e minus x minus 2x e to the power minus x minus 2e minus x plus c. That question was slightly harder because we had to do a repeat integration by parts because of the original x squared. Hope you took that in. Next time we're going to do integration of questions where we have exceptions to the letter U and dvdx, and that is when we look at natural logs. Hope you enjoyed it. Thank you very much.